All right, folks, it's Fast Action, Back in Action here. In this video, I want to touch on some applications of our parabolas. Now, we're going to do more of these, but I just want to give a quick side-by-side comparison about parabolas, because parabolas, those problems often bring with them choices, and choices can sometimes be confusing for students. So we're going to take a look at the same problem twice on this video, and we're going to do a little analysis of how we could choose things to work on this problem. So let's take a look at our first scenario here, and both problems are going to be based on this up here on the top. So we have a suspension bridge. If you're not sure what a suspension bridge is, think about the Golden Gate Bridge in San Francisco. So we've got a suspension bridge. It says that as these cables come down, they are going to be in the shape of a parabola, and they're actually going to touch the roadway of the surface halfway between each of the pillars. So we're going to have some pillars, we've got cables that come down, and they're going to touch right here, and this is going to be a midpoint. Then the towers that support the cables are going to be 600 feet apart, and you can see that I've already marked this information in the picture for us. Our towers are going to be 80 feet high. I've got that listed here as well. This is all going to remain the same for both scenarios. What we want to think about when we're working with a parabola is, first of all, the fact that we have 4 different equations now that we could use to write an equation to represent this parabola. Furthermore, we get to choose, because it didn't tell us, we get to choose where we want origin to be on this problem, okay? Now, I am going to let origin be, for this first one, we're going to let our origin be at the bottom of the tower on the left. So we're going to put our origin over here on the left, and to do that, what then we're going to do to help us really represent this is we're going to draw in our XY axis that's going to look now like this, okay? So that makes this point right here 0, 0. What that's going to do then is it's going to change where some of our other points are. That means that to get to this point here, if this is going to be 600 feet across, that means that I'm going to come over 300 to get to here. So this is going to be now the point 300, 0. And then if I keep on going, this point over here is going to be at 600, 0. That means that this point up here at the top of our tower, since we know that this is 80 feet high, this point is now going to be 600, 80, okay? Now, what it does also tell us is that this point right here, so we've got this point right here, and we want to write an equation for this parabola here, and we're going to ultimately end up working with this point right here in our point in our part C. So let's jump into this part A and start building this equation. And in this first step, I want us to look at vertex form, our old vertex form from our Algebra 2 days. So we reviewed this at the beginning of the year. It would look like this: y equals a, and we'd say x minus h squared plus k. We, of course, now know our vertex, so we can keep going. We're going to say y equals a. We're going to say x minus 300 quantity squared, and that would be plus 0. Now, of course, you don't have to write the plus 0, but I'll go ahead and write it for us right now. Then the next step, we still need to solve for this a value. So we're going to use this xy pair up here that we know to continue solving. So I can fill that in, and I'm going to have an 80 for my y. I know I'm going to have an a. I now know that x is going to be 600 minus 300. That's going to be quantity squared, and now I'm going to drop that 0. If I keep solving this, what I will end up with is 80, and then over here, I'm going to have my 600 minus 300 squared. That's going to give me a 90,000, pretty big, a 90,000A. Now, if we divide both sides by that 90,000, we will get A is going to be 80 divided by our 90,000. And we can, in fact, on this one, it beautifully reduces to 1 over 1,125. So we could write the equation for this parabola as y equals 1 over 1,125 x minus 300 squared. Now, taking that form, I'm going to write it up here on our part B. I'm going to take that form up here and I'm going to rewrite it. Y equals 1 over 1,125 x minus 300 squared. We can actually rearrange this if we wanted into our new standard form by simply multiplying both sides by that 1,125. And that's going to get us our new standard form. Now, some people actually might want to try to work with this new standard form to begin with, but personally, I don't think this would be your easier one to work with because our vertex form is just going to beautifully connect to the vertex that we've been working with, and we already know how to do that from our Algebra 2 days. So unless it asks you to use this new form, I wouldn't probably worry about it. Now, on the next part of this, what we want to do is we actually want to find something significant. We want to find the height of the cable at a point that's 150 feet, and the key here is from the center. So our point 150 feet from the center is going to be, we're going to have to go over our 300, and then we're going to go over another 150. So this is going to be 450, and we don't know the y value. That's what we're trying to solve for. So we're going to take this new value here and substitute it into either one of our equations. Okay, it doesn't really matter, again, which one you choose to do. I'm just going to go ahead and grab our first one that we already did, because why not? We've got 1 over 1,125. We're going to fill in our 450. Oops, I meant to say minus 300 there. I got ahead of myself. That should say 450 minus 300. That'll be squared. And if you type that into your calculator, you are going to get a nice 20 feet. Now, I will also point out that you could also have done this instead of thinking 150 in this direction. You could have gone 150 in that direction. So you could have also done the same problem this way and done 150 minus 300 squared, and that's still going to give you the 20 feet, okay? So that is one example of how to do this problem. Again, that was choosing to put origin right here at the bottom left. Another possibility is to, exact same scenario, so another possibility is to put origin where the cables actually touch the surface of the road. So now our XY axis is going to look like this. So we're going to have that y-axis there and the x-axis here. So now this is going to be 0, 0 right here. And now our points are going to change a little bit. If this is still 600 feet, then over here is 300, 0. This is a negative 300, 0. Then if our tower is now 80 feet, is still 80 feet, this ordered pair changes to 300, 80. Ultimately, we're going to look for, again, the 150 feet from the center, so we can either go 150 this way or 150 that way. I'm going to stick with my positive, and that's what that ordered pair is going to look like. We can do the exact same process, and we are going to end up with the exact same equation. I'm going to start off with that y equals a x minus h squared plus k, but now our h and k are both 0. So this problem all of a sudden looks a whole lot easier because we have y equals ax squared. Okay, that's really all that we've got there. Now, if we're going to go ahead and fill in our ordered pair of 300 and 80, we're going to have an 80 here. We don't know a. We're going to fill in our 300 and square it. And sure enough, you get right back to the exact same thing that you had before solving for the a. You're going to have your 80 divided by your 90,000. So you get the exact same equation that we did before. You would have y equals 1 over 1,125, and now you're going to have an x squared because our origin is at, or our vertex is at a different place, okay? If we want to rearrange this into the new standard form, same deal, we'll just multiply both sides. So we'll have 1,125 y equals x squared, and now it satisfies that. We can then come down here and find our height again, but this time we have to think in terms of our new center. So now we're going to be that 150 over, so it's 150 we're going to put into our equation. So I'm going to have y equals 1 over 1,125. Now my x value is 150. I'm going to square that, and if you type that in your calculator, you're going to get a nice 20 feet again. So what I want you to realize is that you have choices. You can work with your vertex form. You can choose to put the origin here. You could put origin here, but you have to choose and just recognize that if you're working with someone else or you're looking at an answer key, they might do their method a little different than yours, but in the end, everybody should get the exact same answer for the height of the cable at a particular spot.